Hello everyone. Today we are going to solve question number 75, sort colors. So in this question, what we will be given is, we will be given an array where the colors red, white and blue are represented through 0, 1 and 2 respectively. Okay. What you have to do is, we have to do an in-place sort so that all the reds are together and are the beginning. Then we have whites collected together. Then we have blues. Okay. So we are also given an example here that this nums over here, okay, and the final output is like this. And since the representation of color red, white and blue is like 0, 1 and 2, so in the end we have to return a sorted array. Okay. And it's also mentioned here that you cannot use inbuilt sort function. Okay, so this is inbuilt sort function, you can see here. If you just comment out and then run it, then it's going to solve the question. Okay, so this is the final thing that you have to do. Basically you have to sort it. Okay, so let's see how we can do this. So I've discussed two methods in this video. Okay, one is count one and the other is optimal solution. So to let's discuss the count method. Okay, so basically what you have to do is, these are the constraints of the question. Okay, what you have to do is, we have to initialize three variables and count number of zeros, 1 and 2 in these three variables. Okay, so zeros, ones and twos are counted in these variables. Okay, so step 2 is traverse and count, and then step 3 will be just to override the values with number of zeros, ones and twos. So it's standardized that the number of zeros here are 2, the number of ones are 2, the number of twos are 2. So first two elements are overridden by 0, next two with 1, and the end two with 2 respectively. Okay, so this is very simple. You just have to declare three variables, then count them, and then you have to override. Okay, so let's code this one. First thing what you have to do is, you have to declare the counting variables. So in 0, zeros is equal to 0, int ones is equal to 0, int twos is equal to 0. I've declared three variables over here. What we have to do is, now we have to iterate over the array. So int I equals 0, I less than nums dot size I plus plus. So now we have to count this. Okay, so if nums of I equals 0, then we have to do zeros plus plus. Else if nums of I equals 1, then we have to do ones plus plus. Else, since both cases are handled, now we have to do just twos plus plus. Okay, so this way we have finally counted all the number of zeros, ones and twos. Now what we have to do is, we have to iterate over the array again, but we are not going to use for loop this time. What we are going to do is, we are going to utilize these variables and we'll just run for the that number of times, and we'll keep a k. Okay, we'll keep a k. We'll keep a k to like put how much of the array is traversed and for what array we have to traverse. Okay, so let's say we had k equal to 0 first. Okay, we have k equal to 0 first, it was here, then we fill two zeros, the k will be here. Okay, this way we are going to fill it. Okay, so first int k equals 0, then what you have to do is, while zeros minus minus, so in the end the zero will reach, zeros variable will reach to 0, and this loop will automatically uh, like invalid to be entered. Okay, so then we have to do nums of k plus plus is equal to 0. So we are filling it with 0. So initially k was 0, so nums of 0 was filled with 0, and then k plus plus happened. Okay, same way we are going to do while, okay, let me just copy it. So same thing we are going to do with ones. So we'll fill one over here, and same thing for twos. Okay, and then we are going to fill two. You can also write these in 3 steps, but I just prefer this s- cleaner version. Okay, so it's accepted. Let's submit this. Okay, so we have done this question with of n time complexity. Okay, so basically it's a very simple method to solve this question. If you feel ambiguous about this, I can just rewrite one of them for you. Okay, so it just looks like it's okay. It's simply this one and then k plus plus. These both are same thing. Okay, this one and this are just same thing. Okay, now what we have to do is we have to use the second approach to solve this question. Okay, so the second approach that we are going to discuss is the optimal approach to solve this question. This is also known as the Dutch national flag. Okay, the same constraints for the question. What we're going to do is we are going to initialize 3 variables to describe 4 regions. What are the 4 regions are? These are these 4 regions. Okay, first region will be 0 to low minus 1. Okay, so L is for low, so 0 to low minus 1 will be having all the zeros. Then from low to mid we are going to have all the ones. Okay, and then from mid to high we are going to have unknowns, and then from high to end we are going to have twos. So this is how it looks for a random iteration. Okay, so L will be here, all the values in the left side of L will be zeros, and all the elements between left and mid are ones. All the elements from mid to right are invariants, and the value at the right side of R are twos. Okay, so let me visualize you one of the uh, iterations. This is random iteration X. Okay, at the given point of time L reached here. Okay, L contains 1 and all the elements in the left of it are 0. Elements between are 1, you can see here, and these are uncertain to us. And then we have right. Okay, so as you can see here, the element here is 2. Okay, so we are going to have these two L and R as a gatekeepers, so that all the elements at left of it L are zeros, all the element right of R are 2, and the the mid is traversing from L to R. Okay, mid is traversing from L to R, and when once it reaches R, that means all the elements have been processed. Okay, so you can see here we have element 2. Okay, so 2 should be in this place. Okay, 2 should be this place. So what we are going to do is we are going to swap it. Okay, we are going to swap this with this. So we are going to, as you can see, in this x plus 1 iteration we have swapped this with this, right? And we are going to r minus minus only. Why? Because we don't know if this element was a correct element or not. Okay, we don't know it was 1 or 0 or it was already a 2. We don't know it. So what we're going to do is we are not going to do met plus plus in this case. This is very special for this this algorithm, that uh, if we are replacing it with right side we are not going to do met plus plus. Okay, and let me proceed with the next iteration where we have 0 at mid. Okay, so what we are going to do is, since it's a 0, it's going to be swapped with left, and then we are going to do L plus plus and mid plus plus. You can see the difference, that when we was swapping with right, we are not doing mid plus plus. Okay, we are not doing mid plus plus, but in our left, when we are inserting something in the left side where zeros are input, we are doing left plus plus and mid plus plus both. Okay, so we have discussed the algorithm. Let's code it. Okay, so what we have to do is we have to keep four regions. For these four regions we need three variables. So int l equals 0, int r equals 0, int mid is equal to nums dot size minus 1. Okay, so I have these three variables. Oh, sorry, mid should be here, and yeah, r should start from the right side. Okay, now what we have to do is we have to iterate over uh, this array till mid reaches r. Okay, so while mid is less than equal to r, okay, this is a closing condition. What you have to do is if it's not disturbing you, so if nums of I equals 0, nums of I, oh sorry, nums of mid equals 0. If it's 0, what you have to do is you have to swap it with nums of left and nums of mid. Okay, we have to swap them, and then we have to do L plus plus, and we have to do mid plus plus. Okay, next thing, next case will be else if nums of mid equals 1. if if it's 1, then we can directly just skip this variable because it's already in the right place. Okay, so let me keep a condition like if it was already 1. Okay, if it was already 1 over here in this case, then what we would have done is we would have just done l plus plus for the next iteration. Okay, for the x plus 3 iteration we will be doing mid plus plus. Okay, we because it's already in its right place. Okay, else what we have to do is we have to swap nums of mid with nums of right. Okay, and then we have to do right minus minus. Okay, we don't have to do mid plus plus, or we will miss an element. Okay, don't do mid plus plus. Okay, so this is, I think that's done. Let's run this. So it's let's submit this. So yeah, we have done this question using the two best approaches to solve this question. Okay, I think it was easy to understand this because it's nothing hard. We have to just uh, take care of these invariants. Okay, the ambiguous part and the right side, the left side, and the middle part. Okay, so that's it for today. Thank you for watching.